Okay, guys. Yesterday's problem was very easy, so I tried. This one isn't that hard, but I don't think it's that hard, but it's a bit more difficult. So let's solve this. So P, I should zoom in. Um, okay, here we go. Px squared plus 3p squared minus p cubed, p cubed x minus 3x is equal to 0. So we just have px squared minus p cubed plus 3 times x plus 3p squared is equal to 0. Okay, so just plugging 6 in here. Oh, shoot. Plugging 6 in here, we get 36p minus 6p cubed plus 18 or minus 18 minus 18 plus 3p squared is equal to 0. Ooh, this is another quadratic, I think. How fun. Oh no, this is a cubic. Oh man. So, um, okay. First off, yeah, that's great. Cubic here. So, if we simplify this cubic, we have negative 6p cubed, not simplify, but move the terms together, plus 3p squared, um, plus 36p minus 18 is equal to 0. So, can I think of anything? 1 might, no, 1 wouldn't work. 2 maybe? Yeah, that's fruitless. Maybe let's try to solve it with the quadratic equation. I have an idea. We could use VLS. X equals 6 is one of the two rational solutions. So we have, uh, if we say P and Q, we have PQ is equal to 3P squared, and P plus Q is equal to, it's equal to, wait, is PQ equals that, but it's equal to negative. So, right, because it'd be x minus 3 times x minus 2. So they would add together to negative 5. Yeah. So negative, we just get p cubed plus 3. Okay, so we know p is equal to 6. So then 6q is equal to 3p squared. So 2q is equal to p squared. So we know p squared has some, both of these are divisible by 2. Because this has to be 2 times 2 to get this. Because, like if you were to take the square root of both sides, it can't be irrational. We know q is a perfect square. Because it has an extra factor of 2. Okay, and then putting this in here, we get q is equal to p cubed minus 3. Oh, and then we could just get a simpler cubic, putting this in here. we get 2p cubed minus 6 is equal to p squared. So 2p cubed minus p squared minus 6 is equal to 0. 2p cubed minus p squared minus 6 is equal to 0. So p, let's say p is equal to 3. No, that's too high. Well, okay, what would this look like? If it's p cubed is like that, minus p squared. So it would be brought down like that, I think. No, that's incorrect. Okay, continuing. Let's say p is equal to 1. Then it's 2 minus 1 minus 6. Yeah, no. P is equal to 2. Then it's 16 minus 6, which is 10 minus 4, which is 6. So no. P is equal to 3. We get no. So P is not greater than 3. P is less than or equal to 1. Less than 1. P is equal to 0. No. P is equal to negative 1. Then we get negative 2 minus 1 minus 6. No. P is equal to negative 2. We get minus 16. Yeah, that's not going to work either. Well, let's do some analysis. If we get P is equal to 2, then we get 16 minus 4 minus 6. That's equal to 6. So that's of course positive. P is equal to 1. We get 2 minus 1 minus 6. So that's negative. So it's going to be in between 1 and 2. P. Should we try like 3/2? That's 2 times 8. No, that's not 8. 27 over 8. Minus 9 over 4 minus 6. So this goes to 4. 27 minus 9 is 18 over 4 minus 6. 18 over 4 is like 4.5. So this is going to be negative. So what was 1 was negative. It's going to be between 3/2 and 2. What about root 3? Yeah, no. I don't know. What did I do wrong? Let's look at this problem again. Yeah, let's do the quadratic formula. So we have x is equal to negative. So it's not going to be negative, it's just going to be positive. P cubed plus 3 plus or minus the square root of p cubed plus 3. Oh my gosh. Squared. Negative b plus or minus the square root of b squared minus 4 times p times 3p squared all over 2p Wow, so that's a lot. That's not going to work out well. Why did I use P if P is already here? That's stupid. um, X equals 6 is one of the two rational solutions, so I think rational implies that we should use V of S. So if we do that, we get, I'm gonna erase this, call this K. So we know so KQ is equal to C. KQ is equal to C, which is that. And K plus Q is equal to, yeah. So then we're just left with that. What if we have to find P or what if we plug Q in? So we say here, root 2Q is equal to P. So then we have here Q is equal to 2Q root that cube minus 3. So then we're left with, then we're left with Q is equal to 2 root 2 root Q minus 3. Maybe I should Q minus root 8 Q cubed minus 3 is equal to negative 3. Or root 8 Q cubed minus Q is equal to 3. Or we could take out Q and say Q times root 8Q minus 1 is equal to 3. Oh, I see. 3 can only be, this is rational. 3 is equal to 1 times 3. So either Q is equal to 3 or 1. But that makes no sense. Let's say Q is equal to 3. Then we have square root of 24 minus 1, which is clearly not equal to 1. Yeah. I don't know. It's 1/4. So it turns out it doesn't have to be an integer, it just has to be rational. So they factored the quadratic. And they did use the quadratic formula, and that worked out for them. Interesting. Yeah, so I guess you could have used the quadratic formula, and that's what you're supposed to do. But, thank you guys for watching. See you guys tomorrow. Bye.